Hey guys, so today we're going to talk a little bit about load balancing. Everybody loves hearing about load balancing, but I thought in this video I'm going to continue this small series of mine about the different concepts that are, in my opinion, very vital to at least have a basic understanding of in order to work at scale. And when I say scale, I mean you have thousands, if not millions, of users, way larger than a small individual project or a small personal website. So let's get into it. So a load balancer is basically an application or think of it as a route manager. So basically the usual flow that happens when you make a request or from your browser to or not necessarily your browser, but in this, for our conversation, we're going to assume that you're in a browser. So when you hit a web page, what in a common situation happens is that the request goes from your computer directly to the server, or basically the other computer that is running the application that serves up the web view and does all the things that, like Facebook or so forth. That's usually mentally that's the way that it works. And if you say that you do local development, if you have your own little server on your environment, and if you've played around with servers, you know that classic is that you put it on some port. So you go to localhost 8080 or 9000 or 3000 or some port number, and there you have your local web page. And that's exactly the flow that most people conceptually think about when you talk about web applications. Now, but when we have something at really large scale, we have a bit of an issue. And the most fundamental problem that you face at scale is not with the code, it has to do with performance. And you can think about it I think that the best way to illustrate it is think about Facebook or Google. Let's take even worse, Google. Google's search engine represents roughly 44% alone. 44% of all the world's network traffic. They are getting billions of requests. Probably I won't even guess how many billions of requests they get per minute, but we're talking about a lot of traffic. And as you can probably guess, that amount of that many users and many requests, it's not possible for a single computer to be able to handle all of that in any sane way. It won't work. I mean, if they had a single computer, the whole system would crash over and over and over, and you would never get to the web page. So the way that you used to solve this problem was that you created something called a mainframe, because computers used to be very expensive. And a mainframe was just this giant computer that had a lot of memory, a lot of CPU, and could manage basically a lot of traffic, if you will. You allocated basically a lot of resources. This is called scaling vertically, creating large computers. But in more modern practices, we have realized that now the computers are much cheaper. It's actually not feasible. It's much more sane, if you will, to have multiple computers and basically try to allocate the different computation loads on the different computers. Instead of having one big computer, you have an entire server hall with many smaller computers. So what a load balancer allows you to do is that it's something that you put in front of a cluster of a lot of different computers that are all running your application. So what happens is that now, instead of a request, like the browser's request is not now directly going to one single running computer or instance of your application, because you can have 2, you can have 4, you can have, in Google's case, they probably have thousands of computers running their system. And the load balancer conception now, what it will do, it will be the entry point into this network of services, if you will. And it will decide who's going to get the request. And if you have 3 instances of the same application, it's just most of the common cases that it goes to instance 1, and then the second request goes to instance 2, and the third one goes to 3, and it rolls, it just keeps on allocating that. And what happens is that now you can add or remove as many instances as you want. You can scale your system very, very effectively without ever having to worry about changing a lot of configurations and so forth. So this is an extremely powerful abstraction layer on top of your internal network. So all the load balancer does, that's all it does in general, is that it directs traffic to different computers. That's what it's there for. And this is extremely important when you get up, as I said, to the higher scales, because odds are that you're going to start with one single instance. Oftentimes, I would say if you are, let's say that you're not completely just starting out, you may have scaled up a little bit. You might have 2 different, let's say you're actually making money off of your product, right? What usually you will do then is that you will have at least 2 running instances of your application, because what happens if one goes down? Well, then you have the other one to fall back on. And also, if you want to update your system, you could do something like a rolling update, where you update, you funnel all your users to one of your instances, and let that so everybody's working with one instance, and when the other one is completely free of network traffic, you update that one, and then you roll everybody over to the new instance, and you do the same thing for it. Like, a lot of these things are very automated, but that's in essence what the load balancer allows you to do. So it allows you to add or remove or scale. That's what the term scale really very often is associated with. You can add or remove basically instances of your application without having to change anything basically on the request layer, basically the stuff that's coming in, because for the browsers and so forth, they just have a single IP address that they always hit, and then the load balancer will simply allocate based on what the client is asking for. That's like a very basic understanding of what load balancing is, and I urge you to have a good look at that, because it's something that I would say load balancers and containers such as Docker and Kubernetes and so forth, these are very core concepts for you to understand if you want to work with really, really large systems. But hopefully this was useful to you. Have a great day.